All right, so let's get started. Hello, everyone. My name is Mete Atamel. I'm a developer advocate at Google based in London. And today I'm joined by Mark.
Hi, og velkommen. I'm Mark. Happy to be here today.
Cool. So today we're going to be talking about lessons learned building a Gen AI powered application. But before we get there, we want to take you through the journey of how this app came about and how it started and then how Gen AI helped. And then we'll talk about lessons learned. So because just giving you the lessons without this story doesn't make sense. So we want to lead you through the journey, and then the rest of the talk will be about lessons learned. And if you want the slides, this is my speaker deck, and the slides is already there, a version of it, but this version also will be there soon. So if you want to get the slides later, feel free. All right, so what we're going to do is, as I said, first we're going to talk about the idea of this app before Gen AI, and actually goes back a while, and Mike will talk about that. Then we'll talk about how Gen AI came and kind of restarted our app. And then I will get into the architecture of the app and talk about how we built it, what we use, just to give you an idea. And then we'll talk about after Gen AI. So what did Gen AI do for us? But also what kind of problems it introduced. Even though it helped us with a lot of things, it also introduced new problems. So we'll talk about that a little bit. And then the real part of the talk is this lesson learned. So after all of this, what we learned, we just want to share with you so that you're aware in case you want to use Gen AI in your applications. All right, so with that, I'll hand it over to Mark now, where he will talk about the app, because he's the one who started this app years ago. So I'll take it away.
Thanks, Mete. So I have a theory that every great thing we know about in computing started as someone's weekend project. And to a certain extent, this talk is about my weekend project, or what started out as my weekend project and has grown to something bigger. Back in 2016, I was trying to come up with ideas to highlight some new Chrome features, specifically something called progressive web apps, which are a way of making web apps that look and feel like a native app on a mobile device. And I came up with this idea of creating a trivia quiz application. And my plan was, I feel like the biggest challenge was sourcing the trivia content. And my plan was to find an open source trivia database, which I looked around for and did find. There's something called the Open Trivia Database. And you can go there and specify your inputs and make a RESTful public API call and get back a nice JSON document summarizing the trivia content that you want. So that was all fine. And I was able to craft an app initially that essentially gave you access to all of the content in the Open Trivia Database. But there were some problems with this approach. I'm a bit of a perfectionist, and I didn't really like how this was turning out. There was a limited list of topics. If you noticed in that previous slide, there was maybe 25 or 30 categories, and that was it. And I wanted a much broader scope. There was a limited set of questions and answers. You kind of get what you get. It's a pretty decent-sized collection of questions on the order of 1,000 or more, a few thousand maybe. But it's not huge by web standards. There's a limited format, just all multiple choice questions with 4 answers. It's all English, so sort of US or English-speaking centric content, which I didn't like. I wanted more generality there. There was no imagery, and the main problem was if you wanted to expand that content, you've got to do work. You've got to do the tedious work of actually handcrafting good trivia questions, which is going to slow you down and maybe prevent you from ever really realizing this application. Then in March 2023, we all saw this sort of explosion that came about with large language models. And I sort of immediately, when I saw these language models, I immediately thought about this app. And I thought, that's the thing I've been waiting for. Because with those tools, I can create unlimited content, unlimited topic areas, all sorts of possibilities become available to me that were never possible before. So I created this app called Quizaic. It rhymes with mosaic. And the best way to explain this app is to show it to you. So let's go ahead and do a quick demonstration of Quizaic. So it looks like this. You get just a friendly little brief home page. You can then browse the quizzes. If you hit this toggle here, you can oscillate between seeing all the quizzes or just your quizzes. And then once you have a quiz, you can do things within the quiz, like host it, you can edit it, copy it, and delete it, of course. So let's go ahead and create a quiz. Let's call this test quiz.
Yeah, maybe you can use open trivia dataset first just to show.
Yeah, so if I select open trivia, the quiz topic I get is that fixed list that you saw before, which is fine, but it's way too limited. If I then switch the quiz generator to a large language model, and I'm going to select Gemini Ultra because that's Google's latest and greatest model, and the one that we're finding gives us the best quality quizzes. And here I can enter a free-form topic. Now, I can make this is the great thing, it's just unlimited. I can make it as specific or as general as I want. If I'm a teacher who wants to generate a quiz for your class that's about exactly the thing we covered this week, I can do that. Or if I'm having a party or something and I want to have like a general thing, world history, trivia, literature, whatever, I can do that. So I want to ask some brave person in the audience to give me a quiz topic, and we'll try it out. Did I hear metal? Oh, go ahead. Say methyl. Metal.
Metal, like the mineral.
Okay, I wasn't sure if you meant like music, like metal music, or okay. Let's try metals. We could get specific about certain types of metals and all that stuff, but let's just go with metals. I can select the difficulty level, the number of questions. Let's do 5 questions, and let's do it in English. I'll do another quick test in a minute where I'm going to do it in a different language. But for now, let's just do it in English. The first thing you'll notice is you get a placeholder for the quiz, and that's because these LLMs are slow. And you need to build something into your user interface to condition the user to understand you are working on it, and it's going to take a little bit of time. But notice 2 things. One is that I gave progress, and as soon as it was ready, I gave an indication that it was ready. And at the same time, I generated a unique image, again using generative AI, that's based on the topic. So this is an image, I guess, of metal. So if I want to actually play this quiz, I can select host. Here I get an option to do a synchronous or an asynchronous quiz. What's the difference? An asynchronous quiz means players can play it any time they want and can advance the questions from their player experience. The use case for this, again, go back to a teacher. It's Friday at the end of the week. We just studied metals, and which you do. And we want to give our students a little quiz during the weekend. So we do an asynchronous quiz, and the students can do the quiz whenever they want, and we'll tally their results, and they can advance through it as they like. But today we're going to do a synchronous quiz because we want to have a competition, okay? So I'll say start hosting, and I want you to take out your phones. This is one of those rare talks where the speaker wants you to be on your phone. Go ahead and scan that. It should take you to a place where you identify yourself with a name. And let's see who's going to be first in. AK, wherever you are, good speed there. Why do you have to name yourself, right? Shouldn't the system know who you are? I wanted the player experience to be anonymous. I don't want you to have a Google login or any other login, and I don't want you to have to authenticate yourself just to have fun playing a quiz. So that's why you need to give a little bit of ID. Okay, we now have 60. Can we get to 70? 75.
Wow.
Okay. we'll get a good count of how many people are in this room
Yeah.
this way. 88, slowing down, 90. Can we get to 100? How cool would that be? Come on. Oh, the QR is gone. There we go. That's a bug, by the way. I shouldn't have had to do that, but 93. Is there anyone who hasn't done it yet? Okay, I won't hound you. 93 players, that's perfectly fine. Now, what you'll notice is when I start the quiz, it's going to immediately pop up the first question on your phone, and time as well as accuracy counts toward your score. So let's start the quiz. Which metal is a key component of the production of stainless steel, offering corrosion resistance? So you'll notice at the top of the page, I'm getting a running count of how many of the participants have responded. So that gives me a clue as to when would be a good time to reveal the answer and move on to the next question. I think I gave you each 15 seconds, so you're going to run out of time if you haven't responded. But seems like we're stuck at 75. So if that's because you're having trouble, you're seeing some problem with the app, please come down after this session and talk with me. If it's because you got a little tired of playing already, that's fine. Let's show the results. We get a little histogram showing what was the most popular answer, which was zinc. Apparently the correct answer was chromium, and JJ is in first place. Another thing, if you know about metals and you decide one of these questions or more are wrong, please come see me as well. And part of the talk later on, we're going to talk about how we try to figure out whether these quizzes are accurate and reliable. Okay, next question. Probably move a little more quickly. Brass is an alloy primarily composed of which two metals? Okay, we're getting more responses, this time 83. Let's go ahead and reveal the results. The correct answer was copper and zinc, and that was the most popular answer, and JJ retains their position in first place. Which metal known for its high conductivity is commonly used in electric wiring? By the way, I love trivia quizzes. I love going to pub quizzes, and that's my secret use case, is I want to make this available to quiz masters around the world who hold pub quizzes or other quizzes. We're at 58 of 103. Let's go ahead and reveal. The most common answer was copper, and that was correct. STH has jumped into first place, so this is getting pretty exciting. Next question, number 4. Due to its lightweight and high strength, which metal is heavily utilized in the aerospace industry? Okay, I'm going to reveal a little bit earlier just so we don't lose too much time on the quiz, but the answer is titanium, and most people got that. JOX is now in first place. Okay, we're coming to the last question. Amalgam, a mercury-based alloy, has historically been used in which application? Now, after this question, if you're one of the top 3 finishers, you will get a fireworks display on your phone. So look for that. And 68 of 104. Oh, we did get over 100 players. That's awesome. Let's show the results. The most popular result was dental fillings, and that was the correct answer. Our top 3 finishers are OSC, STH, and Wally. Did you, where are you all? Did you see your phones give a little fireworks display? Yes, okay. Let's give a round of applause for our three winners. Hopefully that gives you a sense of what the app is all about. I said that I would try something with a different language. I'm going to do a quick test. How many of you speak Norwegian? Okay, I'm not surprised. I'm glad, that's comforting to know. I'm in the country I thought I was in. Is it IE? Okay. I've already learned something. That's an embarrassing thing to not know, but thank you for helping me with that. Let's do 3, and let's do a different, should we do Oslo trivia or something local? Oslo history. Let's save it. And while it's thinking, I'll tell you just the backstory on this language feature. I was giving this talk, or variation of it, in Sweden, and I thought, here I am, the ugly American, everything I'm doing is in English. I should really make this talk in Swedish. And then I thought, LLM. I just have to add the words in Swedish to my prompt. And so got up in front of the audience, and I added in Swedish, and I put it in the wrong place in the sentence. I said, generate a quiz based on this topic, fill in the topic, in Swedish. And it interpreted in Swedish as applying to the topic. And my topic was in English, and so it just threw that part away. Going back after the talk, I put in Swedish right after quiz, generate a quiz in Swedish based on the following topic, and it worked. So the lesson is these things are very finicky, and they're very literal. Whatever you tell them to do, they're going to do. So be careful what you ask for. I am not going to run this quiz. I'm just going to show you the questions, and you tell me, oh, there is a feature here I wanted to explain. You see all these people registered? I didn't have to give you another link. I've made these quizzes in this paradigm of a session. So the same exact entry can give you access to multiple successive quizzes, which is kind of a nice feature. Anyway, we're not going to compete on this one. I just want to show you that, does this make any sense? Because obviously I'm not able to read it. And the right answer is 1814. Sound right? Let me show you one more. That's wrong? Okay. Back to the drawing board. How about this one? Does that make sense linguistically? Is it good? Is it proper Norwegian? And slow. No? Okay.
Oh.
Okay, one more. So far we're 0 for 2. How about this one? Is it proper Norwegian? Is it readable? And let's see the right answer. Make sense? Okay. Not a great example. I think I maybe got 1 out of 3 right, but I have the feeling you're being generous with me. But the point is, I got a multilingual feature, and we can argue about how well I got it, but I got a multilingual capability by adding a couple of words to a prompt and tweaking my user interface to let me select a language. And that's a pretty different way of operating than I've ever had in the past, in my past experience with software development. Okay. That's our demo, and we will now move on to tell you a bit about the architecture and design of the application.
Okay, so let's just go through like the design of the app, and then we'll get into the GenAI part. Well, first of all, this is what we have for the app. We have 2-tier, so we have a UI server that hosts the UI, and we use Flutter, which I'll talk about. Then we have a separate API server. It's a Python Flask application running on Cloud Run. And that Python application is talking to the LLM. On the LLM side, we are using Gemini as the model. So Gemini is the model we use to generate the quizzes. And ImageGen is the model we use to generate the image on that topic. And this is all running on Google Cloud, Vertex AI, which is the AI platform of Google Cloud. And for the backend, we are using Firestore, which is a NoSQL database that I'll talk about. And Firestore has this nice feature of real-time updates. So it basically gives you free real-time updates to your browser, and we use that in the application to give you updates about the state. So that's kind of the architecture of the small app. We chose to use Flutter for the client because we want to have a mobile app and also a web application. And Flutter, for those of you who might not know, it's a platform for multi-platform applications from Google. And it uses a language called Dart, which is similar to C# and Java if you're used to it. So I like that it's a strongly typed language, but for the client side. So it worked pretty well for us. For hosting the UI and API service, we are using Cloud Run, which is the container service on Google Cloud. And it's the default place that I always deploy my code to because it gives you flexibility with the containers, but it's also very easy to use. You can actually go from your source code to a running service pretty quickly, even without having to create a Docker file. So that's what we use as well. And it gives you all the features of auto-scaling and monitoring and logging and all that kind of stuff within Google Cloud. And for Firestore, for backend, we use Firestore because it's a NoSQL database. It's a document kind of store. And this goes well with quizzes because quizzes are kind of like documents anyway. And we also have this almost free feature of real-time updates. So anything we change on the server side, the state gets updated in the browser automatically without us having to do anything. So that was also a good choice for us. So that's very quick explanation of what we use. Then we have the typical data structures, like we have admins and generators and quizzes and sessions and results. We have 4 key personas, like the admin persona, the creator, host, and the player. And then different personas have access to different Firestore databases. So this is kind of what they can do in terms of read and write. So I won't go through in too much detail, but just to give you an overview of what they can do and where. And then from here, we have the typical API that you expect, like getting the quizzes, creating the quizzes, deleting the quizzes, starting a game, things like that. And then we use Vertex AI for generating the quiz. And for that, we had to play with it a little bit because you need to do a little bit of prompt engineering. You need to kind of get your prompt right, get your responses right, and play with the parameters a little bit to get it right. So actually, I will show you this. So if you are, let me close this one. We don't need it anymore. Close this one. OK, so this is Vertex AI in Google Cloud. And here, you have access to different models. So the Gemini 1.5 Flash is the latest one. There's some experimental ones here. Then this is where you kind of try different prompts. So normally, we started with something simple, like give me a trivia quiz on this topic. But then we don't want free text, so we added like give me in JSON and give me this category. So you have to play with it to get the results you want. But in the end, this is the kind of prompt that we have. You're a trivia expert and generate a set of multiple choice questions. This is the category. This is the difficulty. This is the number of questions. This is the responses per question and the language that we added later. So this almost came for free. And then we also added some rules. We care about accuracy because we don't want fake quizzes, even though we still get them, and we'll talk about that. We don't want questions with multiple correct answers. So you have to tell LLM exactly what you need, and even then, sometimes it doesn't give you the right thing. And at some point when we were using different models, we had to give some examples of what we expected. But then as models progressed, we realized that we don't need to give examples anymore. By just giving some rules, it was giving us the output that we needed. So once you play with this, you can change the temperature, which is the creativity of the model. You can change the output token limit, which means how verbose you want your output. And then you can just hit submit and just play with it and see what you get through the console. And I think, if we go down here, we should see a response. And then, you see that we get a JSON response with a question, responses, and the correct response, like that. And once you're happy, you can go to get code. And then this gives you the code in Python, but also other languages, Node.js, Java. And it's not in here, but if you are a C# person, we actually have some C# examples on GitHub where you can actually do this kind of thing from C#. So you create a prediction client and set your parameters with your prompt, and then just get a response. So all of this is also possible in C#. It doesn't have to be Python. I mean, Python is the language of GenAI, but it's actually not true nowadays. Like you can use whatever language you want. Like we have SDKs and libraries for that. All right. So that's how we got our prompt and quiz generation working. And if I go back. So in terms of quiz generation, so initially, as I said, we had the open trivia quiz generator, which was static. So you only had like certain topics, and you only use open trivia data set, so it was very limited. Then we initially started using PaLM, which was the model that came out from Google in March 2023. This kind of worked, but it wasn't that great in the sense that it wasn't as accurate as other models. Then Gemini came along with Pro and Ultra versions, and that's the latest one that we are using right now. But we still kept the PaLM and other ones just in case we want to test with it. And the prompt, so how do you get quizzes? I showed you this already. So this is the prompt that works for us today. But we always kind of tweak it as we go along or as we try different models. And sometimes you need, even though we think this works, you still need to do a little bit of post-processing afterwards. For example, sometimes we get JSON, and it's correct JSON, but sometimes we actually get JSON like not in Markdown or something like that. So it's not proper JSON, so we have to do a little bit of post-processing. But for the most part, this seems to work. And the code is very simple. I mean, this is Python, but it's as simple in C#. It's literally just define your model, define your parameters, and pass in your prompt here, and then you just get a response that you need to parse. So it's just one call. For image generation, we started with image gen 1, version 1, and then we switched to version 2 when it came out. And version 2 is basically the better version of version 1. And to use that, again, it's a single call. So you define your model that you want to use. So this is the version 2 model. And then you have your prompt. In this case, our prompt is very simple. Photorealistic image about topic. And then you can specify number of images you get back. In this case, just one. And you also have this negative prompt where you tell the model what you don't want. So in this case, we just said blurry. We could probably add more things here to make it more appropriate for quizzes, but this seems to work pretty well as well. All right. So after we implemented this, now I want to revisit the problems that we initially had with this application. So if you remember, we had limited set of topics. Now with GenAI, we can do pretty much any topic. We had limited questions and answers. Now again, everything it's pretty much like unlimited questions and answers. We had limited format, multiple choice for questions. In this case, you can have different formats. You just need to change your prompt. We are still using multiple choice, but we don't have to. We can have more than 4 answers. We can have free form. We can have pretty much any format we want. It used to be English only. Now it's any language. There were no images. Now we can generate images on demand. They might not be great, but at least it's an image that we can use. And expanding quiz content was very difficult before. We had open trivia, and we couldn't really expand it beyond that. And that's what kept the app in its state for like a few years. But now with GenAI, expanding the quiz content is really easy. But with GenAI, we now have new problems. First of all, the learning curve. So, being software engineers, we are used to our tools and our languages and stuff like that. But with GenAI, you're entering to a new landscape where you have different models, different platforms, different frameworks, and you need to kind of figure it out. Like, well, what do I use? Can I use C# here? Can I use this model? Or for image generation, which model should I use? Or should I use Gemini Nano or Gemini Ultra? So there's a lot of things you need to kind of figure it out, and there's a little bit of learning curve there. And the landscape is changing quite a bit. Just within 1 year, we went from PaLM to Gemini Pro to Gemini Ultra, and now we will probably use Gemini Flash. PaLM had its own API and libraries, and then when we switched to Gemini, we had to use new libraries. So it's a very fast-changing landscape, not just within Google, but also outside Google as well. And you need to kind of keep up to date and kind of figure it out, what I should use, which libraries, and make sure you are using the right things. One of the biggest problems with LLMs is you will have inconsistent or no output sometimes. for no reason. That's just the way they work. Like, it's not like if you pass in the exact same input twice, you might get different outputs, and you need to be comfortable with that idea. You know, again, as software engineers, we're used to having consistency. So if you call something, you expect the same response. But with LLMs, that's not true. And LLM calls are slow. So it's not like a normal API call. I mean, sometimes it's really quick, but sometimes you need to wait a little bit to get an answer. Sometimes it doesn't respond. Sometimes it responds with something that's not true or no output. So you need to deal with that. Hallucinations is a big problem. As you've seen in the Norwegian quiz, sometimes it tells you the wrong thing. And maybe it's OK sometimes, but sometimes it's not OK. So again, you need to deal with that as well. And I think the biggest and most difficult problem is how do you check the accuracy and quality of LLM outputs, okay? And you know, it's easy to get content out of LLMs. You can get text out, you can get images out, but then how do you know that that text is what you wanted? How do you measure it? How do you know that the image is actually what you want? What's the quality of that image? Like, that's very hard to check. And you need to, again, do things to kind of measure that. And we'll talk more about that shortly. All right, so that was a very quick overview of the app, where it came from, and how it works, and what it solves, and what it introduces. Now we want to switch to the real meat of the talk and talk about what we actually learned throughout this exercise. So I'll hand it over to Marc, and yeah, let's go through that.
Thanks, Mete. So I'll start with a couple of general things. One is it's surprisingly easy to do what used to be hard with GenAI. I guess the language capability is an example of that. You know, I've been developing applications since I started my career in 1982, so a little over 4 decades. And this has really changed how I think about building apps, which is pretty significant. Some of you may have seen this tweet from Andrej Karpathy, where he said the hottest new programming language is English. And I would now say it's Norwegian, of course. But the point being, natural language programming has arrived. But with that power and convenience comes a lot of kind of things you need to deal with, to worry about. Quiz image generation with a single API call is another example of how powerful this is. On the other hand, it's hard to do things well and consistently so. Good results require very specific prompt engineering, and then once you've optimized your prompt, you may find you need to keep working on it. That's almost like your software life cycle, where you're finding and fixing bugs all the time. And you will get inconsistent outputs no matter how hard you try. And so you need to adopt a belt and suspenders kind of approach, where you kind of codify in the prompt exactly what you want, but then you don't assume you're going to get it. You sort of still code to deal with what might happen if you don't get exactly what you want. A good example of this is early on I was asking for the quiz in JSON, and it was working great, and then a version of the model came out where it would prefix the JSON with, "Here's your JSON." Like, thank you, you just blew up my app. And then I realized it's not its fault. I need to be sure I deal with the fact that I might not get perfect JSON. So I strip out anything that comes before the beginning of the JSON. And then, of course, I got something after the document. I won't keep going with this story, but you can imagine why it can be frustrating, and you need to keep worrying about coding defensively, basically. The other hard part we've already mentioned is hard to measure the output quality. By the way, it's easy for a human being to measure the output quality, but that's not good enough, right? We need automation and engineering practices, so we're going to talk more about how we're doing that. Accept the uncertainty of an LLM. This is a bit repetitive, so I'm going to kind of go through this quickly, but the same prompt, same model can give you different output. The same prompt, same model, the model can get updated to give you different output, and so on. So just expect the unexpected when you're working with these things. The good side of that story is that when a new model comes out, suddenly your app gets better, and you didn't have to do any work, quote unquote, other than test and verify and adopt that new model. But we saw that in practice when we started with Palm, and the quizzes were so-so. And then we moved to Gemini Pro, and the quizzes got better, but they still weren't great, in my opinion. And then we went to Gemini Ultra, and they're even better. So every time these models get better, and I'm talking across the industry, not just Google, it's, the high tide raises all boats kind of a thing. Every app that's depending on these tools is getting better, which is pretty cool. Same with image generation, and got all that value with little or no code changes. Another thing to ask yourself is, do you even need an LLM? One sort of pitfall I fell into was I sort of fell in love a little too hard with these things. Like I was like, wow, I can do anything with these things. And you have to remember the costs, and you don't want to do everything with them. A good example was at one point I was working on free-form quizzes. So this is where it says, fill in the answer, and you don't get the choices, you just have to specify the input. Grading that can be very tricky, right? Humans have very fuzzy linguistic ways of expressing a given answer, and you have to decide, is this answer correct or not? And I started going down the road of, I know, I'll ask the LLM. Bad idea, because number one, that's a lot of propagation delay and latency in the user interface. It's very inefficient. But number two, there's a much easier way to solve it that's fast and understood, which would be like a Python library or whatever language you're working on, which does Liebenstein distance or fuzzy matching, things like that. It may not be as good as the solution you want, but it's probably going to be good enough. Another example was just this little sort of logo that you see. I spent weeks trying to generate that with just the A and the I in red. I can't tell you how bruised my forehead is from banging it against the wall, trying to get that to happen. If you know how to do that, tell me, because I've tried everything. I was talking to Mete, and Mete said, why don't you just use Photoshop or something like that? I was like, yes, why don't I? So sometimes there's a good old-fashioned way to do things. You don't have to do everything with the new cool stuff. And that avoids an expensive call to what is probably a little bit on the slow side functionality. Prompting, be very specific, as I've already mentioned. More detailed prompts doesn't always lead to better results. Manage your prompts like code. It is a critical part of your application now. Version your prompts, of course. The output parsing and the prompting kind of go hand in hand, so you want to think of those two as a pair that you're matching up.
Can I say something about
Sure.
the previous part? So in terms of the more detailed prompts not being better results, this comes from me because as I was doing prompt engineering, I thought, okay, I can give a lot of rules, and the more rules I give, it will get better, right? That's what you think. But actually, I realized, like in some cases, the more verbose your prompt gets, then the results get worse as well. So just because you can give more rules doesn't mean that things will get better. And that's a little bit unintuitive for me. So what you will really want is figure out the minimal prompt that works and kind of build on that, but making sure that every little thing you add to your prompt actually makes things better. And for that to happen, you need to be able to measure things, and we'll get to that later. But yeah, so this is one thing. And the second thing is that, so there's two parts to the LLMs. One is the prompt. The other is the output you get from the prompt, right? And you want to be able to correlate them. Because as you iterate on your prompts, you probably want to version them so you can keep track. But then, as the prompts change, the outputting, how you parse it will also change. So it's good to kind of have it in your code as well, the same kind of versioning, so that when you change your prompt, you know how to parse it, because it will change depending on the prompt. So I just want to make sure that we cover that, because it will save you a lot of frustration when you're iterating on your prompts.
Right, thanks, Mete. And then the example I gave earlier about where it gave me information I didn't expect, I didn't mention this, but I fine-tuned the prompt. That was my first attempt. And what I said to it was, give me a JSON document and only a JSON document. So I was very explicit in my prompt. I don't want anything but a JSON document. And that fixed it. Like, it seemed to work perfectly. And what I found was 1 out of every, 50 times, it still did the wrong thing. And so then I realized, okay, even though I got the prompt to be 98% accurate, I still need to add the code to make sure it does the right thing. And which brings us to code defensively. I've already hit that pretty hard, so hopefully that's clear. But the LLM can fail, and in addition to not getting exactly the output you want and dealing with that, also deal with the fact when it just flat out fails. You get something that's just complete garbage. You need to have a strategy for that, right? So that could be retrying some number of times. Of course, you want to keep the user informed of what's going on so they just don't see just a blank screen. But you're raising the ante. I mean, you do this in a traditional app, right? You make a database call and something goes horribly wrong. You might not have worried about it as much unless you're a bank because it would be so infrequent, but it will happen and you need to code defensively. Now you're dealing with something that's probably more temperamental than anything you've used before, and so the defensive code and the recovery strategies are even more important than they were in the past. Yeah, you get some empty results. Can you live with no quizzes or no image? These are questions you have to ask yourself as an application developer. My answer would be no, I can't live without a quiz. I can live without an image. So if the image generation fails, I put the Quizaic logo there as the image for the quiz. Is it perfect? No. Do you get the functionality without having to lose the whole workflow? Yes. So that's a good compromise, I think. Sometimes you'll find the LLM is too cautious. A lot of the commercial LLMs the providers are struggling with making sure they don't do the wrong thing, however you define the wrong thing. And so you will see that you'll get failed returns because the subject you asked caused it to generate something that it felt was maybe questionable. So you want to look carefully at the safety settings in your application or your API calls and decide for yourself what's the tolerable level of safety for your application. Pinning model versions is really important because if you just use a name that refers to whatever the latest model is, then you leave your application open to the fact that it suddenly changes overnight or in the middle of the day, and your application suddenly behaves differently, maybe differently better, maybe differently worse. And so you want to do this the same way we would do any other software engineering application deployment job. You want to test and make sure you're getting exactly what you want, and only advance and pin it to the version you specifically want, and then advance that when you're ready. Consider a higher level abstraction layer like LangChain. There are different APIs available from Google or any other supplier of a large language model. You can embed those into your application. In Vertex AI, we have different libraries had different libraries, as Mete mentioned, for Palm and Gemini. And that's just within Google. And now, if you want to support other LLMs, you're looking at a constellation of interfaces across the industry. So you want to be able to not have to spend a lot of time reinventing the wheel every time a new LLM is available.
Yeah, and I should add here, I'm a library purist, meaning I like to use the library of the service without having to use something like LangChain, for example, because I feel like that introduces another level of interaction. So that's why we started with the actual libraries of Vertex AI. But then when I see that different models, they end up having different libraries within Google, and then if you want to use OpenAI stuff, then they have their own libraries, but at the end of the day, you're doing similar things. Then that's when I started switching to LangChain, because it gives you this high-level kind of interface that works with a bunch of different places. So my idea changed, and now I kind of prefer LangChain because they have the right level of abstractions. Right. But it's up to you what you prefer.
Yeah, and by the way, there's no right answer here. I'm not advocating everyone here should use LangChain. There's always a trade-off. When you use an abstraction layer, you lose a certain amount of control over what's happening at the lower levels. And hopefully, the benefit you get from that abstraction and not having to code to specific interfaces, it outweighs the loss of control. But every use case is unique, and it's something you want to consider. All the good old software engineering tricks we have still apply. So don't forget, You can do things like batch your prompts wherever it makes sense to get away with, sort of minimizing the round trips to the slow thing, which is the LLM right now. You can parallelize calls, like we don't wait till the quiz is generated before we start asking for the image. We can start them both going at the same time. We can cache common responses. So all those things we've been doing for a long time still apply, and you should still use them. Let's sort of switch gears to testing and validation. So unit and functional tests are as important as ever, as we've discussed. It's easy to check the existence or the format of a quiz. So that's pretty straightforward. Is it a parsable JSON document, which of course you want to do. You don't want to blindly store this quote-unquote JSON output in a database and start serving it only to find out that the user gets a very weird experience. So you want to parse the output, check it exists, it looks reasonable, and it has the right format. Is this a quiz with 5 questions and 4 answers? Does the image exist or not? But that's just giving you, like, technically, did I get back something that sort of makes syntactic sense? But then there's a semantic question. Is this a good quiz? Is this an accurate quiz? And that's much more difficult to check. For example, the person entered history. Is this quiz actually about history? Is the answer it tells me is correct actually correct? We saw a case, or maybe more, where that was, it failed. And we want to understand how to tell if that's happening. Is the generated image appropriate for this quiz? That's an even harder problem, which we haven't, frankly, tried to solve yet. But if we try to focus on good engineering practices, we need a way to measure LLM outputs. So here's my idea. We should use an LLM to evaluate the LLM output as far as its accuracy goes. Everybody okay with that? Most people kind of laugh when I say that, because if you think about it, it's like asking a student to grade their own exam paper, right? It kind of doesn't make sense. If you can't believe or trust the quiz that it generates, why would you believe its ability to judge its own quiz? Well, it turns out it does work, and I'll explain more. But the key is to automate this. Once we're able to do that, to automate it and to use it as a benchmark as we go forward. So here's the vision I have for this, what I'm calling a validator. And we've got it working. It's not integrated into the app yet, but we've got the standalone component working. So the vision is the generator makes a call to the LLM and generates a quiz, as you've seen twice. We take that quiz and we send it to the validator, and the validator asks the LLM to validate the quiz accuracy. And based on that result, we get back something to attach to the quiz. So think of this as a confidence rating. We're not going to know with 100% certainty that quiz is 100% accurate, but we will be able to say something statistically significant. That quiz is 90% likely to be accurate or 60% likely to be accurate, something along those lines. So we're never going to have perfect knowledge, but we're going to be able to infer statistically the quality of our quizzes with this approach. And by the way, I'm not going to advocate that we do this process interactively, because I don't want to make the user wait for the evaluation. My idea in my mind is we'll store the quiz as it is, fire off this validation as a background thread, again, using our good old software techniques that we've been using for 50, 40 years. And then once the validation is done, we can attach the little confidence score to the quiz. Okay, how do we know if the validator works? I'm going to let you take this one.
Yeah. So one question is like, okay, like we can use LLM for the validator, but how do we know that if it actually works? And one idea we had was we have the open trivia as the questions data, right? So why don't we take that and ask LLM to find the correct answer and see how many times it actually does that. So if we do that with the right number of questions, we should get a score. So that's one idea. And I actually, so basically take your quiz, which is an open trivia, maybe change it a little bit, and I'll show you what I mean by this. Then ask the LLM, given this question and these answers, which one is correct, and then get the results. and compare that with Open Trivia and see what you get. So I actually have this small GitHub repo where I did this, like Open Trivia LLM testing. And I won't go through it in too much detail, but I just want to show you what we have. So basically, it's just a Python script where you pass in your Google Cloud Project ID and your model. And you want to do this in iterations because you want to, LLMs, they give you different results, right? So you want to do multiple times with a multiple number of questions and see what you get. And then I run this against Gemini 1.0 Pro, 1.5, and 1.5 Flash. And just to look at the Python script, I won't go through the code in detail, but just to give you an idea what it does, it basically gets the questions from Open Trivia. Then it filters this information it doesn't need, so it only gets the question, the correct answer, and the incorrect answers. And then you don't want to bias LLM with the answer, so you don't want to give the correct answer to the LLM. So what I do here is that I take the correct answer and the incorrect answers and then combine them together into one field called answers. And then I ask LLM, now given these questions in JSON with the question and the answers, can you tell me which question is correct? And then I get the answer back, and then you see I have this remove JSON marker. So in case I get malformed JSON in Markdown, I remove that. And then I do a comparison, basically, and say, OK, this is what LLM says. This is what we have. What's the percentage, right? And what we found out is that Palm, the model that we used initially, it was around 80% accuracy. So it knew 80% of the time if something was correct. So that wasn't that great. Now the Gemini Ultra, the latest one we use now, it's around 94%. So it got better. So it's not 100%, but it's not bad either. So it gets most of the time. So you can take a look at my GitHub repo to see what kind of things you can do. But the point is that you need to have something like this where you can basically measure things in whatever way, whatever you need to measure, so that when you change your prompts, you can kind of see if it made things better or worse. That's the key point here. And there's also something called grounding. So grounding is basically trying to make your LLMs grounded into some data. This can be either your own private data, or it can be Google search. And actually, it's very easy to use. So all you need to do is you create a tool, and you just say, my tool is Google search retrieval, and you pass that tool to your model, and then the model uses Google search to ground its answers. So initially, my idea was, OK, since we have Google search, maybe if I ground my answers to Google search, I will get 100% accuracy because it's going to use search. But in our case, it actually didn't help. And my guess is that it's because we are already using Open Trivia data, which is already out there. So maybe the model is already trained on it. So if you have Google search on top, it doesn't really help. But in cases where you need real-time data, like weather data from today or stock data from today or things like that, where you know that the data is not in models training data, then for those kind of things, Google search actually helps quite a bit. So you can actually get more answers and more accurate answers using grounding. So it's something to keep in mind as well. And if you have any private data where you want to ground it with your private documents, again, you can use that. You can create a tool that uses Vertex AI search to search your own data and give you more accurate answers. And then Mark also worked on this a little bit in a different way, so I'll let you explain this one.
Yeah, so it's sort of easy to get a little confused here because there's a level of indirection going on. So what did Mete just share? It wasn't assessing the quality of quizzes. It was assessing the quality of an LLM to judge a quiz. And what we found was Gemini Ultra is about 94% accurate if you give it a random quiz and it tells you an answer it judges its accuracy. It's about 94% correct. So that gives us the first part of the puzzle, which is that Gemini Ultra is a very good, pretty good, I would say, judger of quizzes. But now we want to take our generated content and run it through that assessor. And so the way we do that is we take a given quiz that we've generated. So here's an example. Who was the first US president? You can think of any multiple choice question. If you remember that game, Two Truths and a Lie, any multiple choice question is 3 lies and a truth. Okay? So if you decompose the multiple choice into 4 assertions, only 1 will be true and the other 3 will be false. So you take those 4 assertions, batch them, because your quiz is going to have multiple questions, and again, you get the benefit of getting everything done in one API call. And then you can ask the assessor or the validator that Mete just described, what do you think of this? So in this case here, you batch it together, these 4 assumptions. In reality, for a quiz, a 10-question quiz, you'd have 40 assertions, and you'd probably shuffle them to avoid locality bias. And the LLM, if you prompt it correctly, it'll say false, false, true, false. It'll give you its reading on these things, and you can compare them to the known values and decide if the quiz makes sense or not, whether the quiz is accurate or not. And what we found out was that running this on Gemini Pro gave us only a 70%, sorry, I need to be careful. Generating quizzes on Gemini Pro and then validating them with the best known assessor, the generator, Gemini Pro, was roughly 70% accurate in terms of its quizzes, which was disappointing. And Mete found that as an assessor, as a validator, it was 80%, but the actual quality of its quizzes was only 70%. So there's 2 different quantities we're talking about. The good news is, looking at this same problem with quizzes generated by Gemini Ultra, has jumped up to 91%. Now, don't take these numbers too literally because they change every day, but the point is Gemini Ultra has proven to be a very good judge of quiz quality and a very good, pretty good generator of accurate quizzes. So what we want to do is operationalize all this into the dynamically testing of quizzes, as well as doing kind of unit or regression test type work where we can, after we have a new version of the model or a new version of the app, we can run a test suite and it'll use the preferred model to generate thousands of quizzes and give us a report, and automate things in the way we always want to do for well-defined software engineering processes. So to summarize all this, we went from, this is a little bit of an exaggeration. I'm kind of implying what would have taken 7 years took me 7 weeks or took us 7 weeks. That's not really true. But there is a kernel of truth there, because the reason it took me 7 years to realize this app was that it was too painful, or maybe not even possible, to build it the way I was dreaming of it being. And once I had access to this large language model, I didn't come up with the version you're looking at today, but I came up with a pretty respectable prototype in 7 weeks. I didn't know Dart, and I had to pick up Flutter on the fly, so that all slowed me down a little bit. But the point is, I went from something I just didn't know how to solve to something that I could solve in a satisfying way in a few weeks. I think that's a lot to do with what generative AI means to me. It makes new things possible that weren't possible or were very difficult. As we use this technology, we just have to keep our eyes open to the fact that it's not free. It comes with a cost as a developer, as a system integrator, as a tester, all those things we have to keep worrying about. So thank you very much for your attention. We're just right up to the last minute. We might have time for one question, or
Yeah, maybe. Yeah.
anyone have any question for us? Yes, right.
It seems like you're taking the user input, the text input in free form, and placing it straight into the prompt. Do you have any recommendations or regards in bad actors trying to manipulate the prompt itself?
Yes.
Like changing the rules or doing
Yes.
stuff you don't want them to?
So the question was, are we taking the user input and putting it straight into the model? Not exactly. I'm using a profanity filter, which is minimal, but you want to do that kind of thing. And I haven't bullet hardened it, to be perfect, but yes, there's a whole school of things you need to worry about, and that falls into that category of this stuff's not free. And by the way, the profanity filter's in that same category I said earlier. You can guess what my first way to do the profanity filter was, and it was wrong. It was, let me ask the LLM, and then I found lots of good, easy to use libraries to do that. Any last question? Was there another one? Yeah. Sorry, there's a lot of noise behind me. Can you speak? Have we played with the temperature parameter?
Yeah, we play with it, and we try to make it 0, expecting that we'll get like perfect quizzes or same quizzes every single time. It's not true. You still get different quizzes, and then we try to move it so that we get more creative quizzes, and they do get more creative, but then you get also inaccurate quizzes. So yeah, we play with it. Did it help? No.
Yeah, I mean, my take on that is we're kind of going with a very simple approach of keeping it at 0 because it's the most reproducible, repeatable thing. But ideally, the end user should be able to specify the temperature value, because you might not care if it's not as accurate, but you get these kind of crazy or interesting questions. So ultimately, I'd like to pass that through to the end user. And for our testing, we should be able to vary the temperature and run different tests. And we should actually see, like, this is the curve, accuracy curve we get as we tweak the temperature. So I think we'll call...
Yeah, I was going to say that. So we will be here outside the room if you have more questions. So feel free to stop by, and we'll be happy to answer. Thank you.
Thank you.